In this video, we're going to look at algebraic equations that require you to solve when there is a variable on both sides of the equal sign. Our first example is 10h plus 12 equals 8h plus 4. And what I like to do first is combine both of my variables on one side. So I'm looking at the 10h and the 8h, and although it doesn't matter which one I start with, I'm going to choose to start with the 8h. So to eliminate it from the right side, I'm going to subtract 8h because that will cause it to become a 0. And whatever I do on the right, I'm going to do on the left, so I'm going to subtract 8h from the other side as well. If I solve this, I'm left with a 2h, and then I'm going to bring down everything else that was in my initial equation. So 2h plus 12 is equal to 4. And you're going to see at this point we're back to having our normal two-step equation. So if it helps you to still draw your house for your two-step equation, here's our house, and the number that's by itself leaves the house first. So that would be the 12. And it's a positive 12, so the inverse or the opposite is to pair it with a negative 12. And again, whatever we do on the one side of the equation, we do on the other. So I'm also going to subtract 12 from the right-hand side. On the left, we're left with a 2h. And on the right, we are left with a negative 8. And I have one more step to go because h isn't by itself yet. And I see here that 2h, they are being multiplied, and I know the opposite of multiplication is division, so I'm going to divide the left-hand side by 2. 2's cancel out. I'm going to divide the right-hand side by 2, and I'll be left with h equals negative 4. So that tells me that if I were to replace each of the h's in the initial equation with negative 4, it would come out to be even. So 10 times negative 4 is negative 40, plus 12 would give me a negative 28. And then if I go on the other side, 8 times negative 4 is negative 32, plus 4 is negative 28. And since negative 28 is equal to negative 28, I know that I got the work correct. Let's look at another example. So here I have negative n plus 5 equals n minus 11. And this time, just to show you that it doesn't matter which side I move, I'm going to take this negative n and I'm going to add n. A negative n and a positive n cancel out, and we're going to add the n to the right-hand side this time. So I'm now left with 5 equals, and keep in mind both of these n's have that invisible 1 sitting in front of them, so I'm really adding a 1n plus a 1n, which gives me 2n, and we bring down the minus 11. And again, you're back to a normal two-step equation at this point, so I'm looking to get n by itself on this side of the equal sign. So I start with the negative 11. The opposite of negative 11 is positive 11. That pairs off to make a 0. We add 11 to the other side. 5 plus 11 gives me 16. And on the right-hand side, I'm left with a 2n. I know that 2 and n are being multiplied, and the inverse of multiplication is division, so I divide both sides by 2, and I'm left with the answer n equals 8. Sometimes you're going to be given a problem, a word problem, and you have to create an equation that looks like this from the information given to you. So we're going to try that right now. So the problem tells me that Jessica wants to rent a bike. The first rental company charges an initial fee of $18 plus $5.50 per hour. The second company charges an initial fee of $12 plus $7.50 per hour. And the first part of the question is asking us after how many hours will the charge be the same. So I'm going to use two different colors. I'm going to start with blue, and the blue pen is going to represent the fees that I will run into if I go with the first rental company. So an initial fee of 18, plus 550 per hour. And algebraically, I would show that as 18 plus 550 times some number of hours, which I'm going to represent with the variable h. Our second rental company I'll do in red. So the second company charges an initial fee of $12 plus $7.50 per hour. So if I had to write that algebraically, I would do 12 plus 750 times some number of hours. And again, I don't know what that is, so I represent it with a variable. And I'm going to choose the same variable that I used on the left-hand side of the equation, which is an h. Now that we have this set up, I'm going to use the same process that I used in my two previous examples to solve. So I want to consolidate my variables on one side. I'm going to try to stick with positive numbers here, so I'm going to subtract the 550h from both sides so that it will cancel out on the lefts, and then I have a nice easy subtraction problem to deal with on the right. So after subtracting, on the left side I'm left with 18. On the right side I'm left with 12 plus 2h. And at this point you have your normal two-step equation. I know that the 12 is by itself and it's a positive 12, so to make a positive 12 0, I'm going to subtract 12. And whatever I do on the right, I'm going to do on the left. So at that point, I'll be left with a one-step equation, which would be 6 equals 2h. And my final step to solve for h, I would divide both sides by 2. And 6 divided by 2 tells me that h equals 3. So in the context of the problem, that means that if Jessica were to rent a bike for 3 hours, it would not matter which one she chose because she would pay the same price. In the second part of our problem, we have to determine if Jessica were to rent this bike for 5 hours, which would be the better choice. So I could think of it two ways. I can take that 5 hours and I can actually substitute a 5 into each of these expressions for h, and I can solve them, and I can see what would be cheaper. Or I can think of it this way. If at 3 hours they are equal, I can basically consider the 12 and the 18 to be paid off at that point. So looking at my hourly fee, I would then either pay $5.50 an hour or $7.50 an hour. And since $5.50 an hour would be cheaper, I would have her go for company 1.